welcome to Tensor Lens. We're going to talk about a math problem so tough it stumped the greatest minds on the planet for half a century. And then, in late 2025, it was completely solved in just 2 days. So let's set the stage. For 50 years, a really tricky question posed by the legendary mathematician Paul Erdos was just sitting there, unsolved, a huge challenge in a field called Combinatorics, known simply as Erdős Problem number 1026. And then this happened. A global team of mathematicians, armed with a new generation of AI tools, didn't just crack it, they speed ran it. The whole thing was over in just 48 hours. Now, this story isn't just about a computer getting faster. No way. This is about a fundamental shift in how we do science. It's a story about a new kind of partnership where brilliant human insight gets supercharged by specialized artificial intelligence. Okay, let's dive in. To really get why this solution is such a big deal, you first have to appreciate the problem itself. What exactly was this enigma that held out for so long? So here it is in all its glory. When Paul Erdos first threw this out there in 1975, it was kind of vague on purpose. Basically, it's asking you to find the heaviest, the biggest possible sum of a chain of numbers inside another sequence, where that chain is either always going up or always going down. But what does that actually mean in practice? Well, to make sense of it, the community came up with this brilliant little game. Imagine two players, Alice and Bob. Alice takes a big pile of money and splits it into some number of smaller piles, all different sizes. Now it's Bob's turn. He has to pick some of those piles, but here's the catch. The piles he picks have to be in a perfect sequence, either getting bigger and bigger or smaller and smaller. So the real question is, no matter how clever Alice is with her piles, what's the minimum slice of the pie Bob can always guarantee he walks away with? And that guaranteed slice, that ratio, is the absolute heart of the problem. It's a constant, and mathematicians call it C of n. The hunt for 50 years wasn't just for an estimate, it was for the exact perfect formula for C of n for any number of piles. Which brings us to the many event. A new kind of scientific collaboration kicks off, and the clock starts ticking. Let's walk through how this thing went down, step by incredible step. So the first domino falls when Boris Alexeev points a specialized AI called Aristotle at the problem. Just an hour later, Koichi-chan confirms its initial findings with a classic human proof. Fast forward a day, and Fields medalist Terence Tao jumps in, feeding the problem into a totally different AI, AlphaEvolve, which spits out a critical pattern. That pattern sparks a key insight from Lawrence Wu, and finally, Terence Tao uses ChatGPT to weave all these different threads together into one unified proof. It was a global hybrid team working in parallel at lightning speed. Okay, so let's talk about what Aristotle did, because this is so cool. The AI didn't just brute force calculations. It made a conceptual leap. It took this abstract problem about number sequences and reframed it as a visual geometric problem about how to best pack weighted rectangles into a square. It actually rediscovered and then generalized an idea from a paper written way back in 1959 by a guy named Seidenberg. Now, with this new geometric angle, Terence Tao unleashes AlphaEvolve. And here's the thing, he wasn't asking it for a proof. He was basically asking it to play the Alice and Bob game over and over to find the worst-case scenarios. And after just 1 hour, the results were stunning. The numbers weren't random at all. They were all narrowing in on these really clean, simple fractions. The AI was basically screaming that there was a beautiful, elegant formula hiding just beneath the surface. This is where the humans jump back in. They took that strong hint from AlphaEvolve's data and turned it into a formal mathematical guess, a conjecture. They essentially reverse engineered the pattern and came up with this exact formula. All of a sudden, they weren't just searching in the dark anymore. They had a very specific target to prove. And then came the big aha moment, a flash of pure human intuition. Seeing the problem framed in terms of geometry, mathematician Lawrence Wu made an incredible leap. He realized that this problem about packing weighted rectangles was deeply connected to a different famous puzzle, Erdős Problem 106, which is all about packing regular squares. So how do you tie it all together for the win? Check this out. Lawrence Wu used an AI search tool to look for papers on that related problem, Erdos #106. The tool immediately found a paper, published just a year earlier, that contained the final missing piece they needed. And with that, they had everything. Terence Tao took the geometric reframing, the numerical formula, and this new link, fed it all into ChatGPT, and had it assemble the final polished proof. Done. Okay, let's just step back for a second. Act 3, Mathematics Accelerated. Because, solving one 50-year-old problem is great, but the process here, that signals something much, much bigger. We're talking about accelerating the very engine of discovery itself.
And you don't have to take my word for it. Terence Tao said it himself. He believes humans could have gotten there eventually, the old-fashioned way. But this new collaborative process, it compressed what would have taken weeks or even months of painstaking work into a 48-hour global sprint.
And trust me, this is not a fluke. It's happening across the board. Terence Tao used Gemini 2.5 DeepThink to solve another problem, #367, in literally 10 minutes. He's using GPT-5 to automate literature searches against the massive online encyclopedia of integer sequences. And just recently, an AI from Harmonic independently proved Erdős Problem #124 in just 6 hours. This is the new toolkit.
The community is adapting fast. On erdosproblems.com, which is kind of the official home for these problems, using AI for help is now just normal. It's routine. But, and this is a big but, there's a critical rule. Any piece of code, any insight, any data generated by an AI has to be independently checked and verified by a human expert. The AI is a co-pilot, not the captain. So let's be really clear about the takeaway here. Solving Erdos 1026 wasn't just checking a box. It's the starting gun for a new era of discovery. The question we're asking now isn't if AI can help us find answers. The question is how fast it's going to help us find the next one. If this is the kind of hardcore engineering analysis you're looking for, and if you want to focus on signal over noise, then you know what to do. Subscribe to TensorLens. Thanks for tuning in.